अरे भाई चल जा. Hello, hello, hello. Hi guys. Yeah, I am late. I know. Audio video is fine. Like, I was making. कहाँ गया यार मेरा pen? Fuck pen कहाँ गया? हाँ मेरा. So for the folks who don't know, like, if the folks have joined in, can you please write down how many questions you did? How was the contest? It was a bit tricky. Especially the last one. It seems easy, but actually understanding that how to think of it's actually a hard part. So yeah, we will see that. But yeah, before that. I have started live. Why it is not showing? Um, Not sure why it is not showing the live thingy. Is it open for you guys? Because it's not open for me. I don't know why. Yeah, it's open now. So quick. Two questions. No, great. Piyush. Any other folks, and yeah, before that, can we please smash that like baby? We will see all four questions very fast. And for the last one also, I've provided the notes for you to refer because actually it was a good question. Last one was actually a good one. Second one was standard one. Third one was a bit standard to a bit like non-standard, but fourth one was actually, although it seems like it's actually a standard one, but it's not. Great. Can we smash that like to 10 likes, and we will quickly start with the problems itself. That's pretty, first one is pretty easy. Maximum achievable, two questions. Akhilesh, take up two. Aryan, last one, can be solved with O of n square. See, if it is being solvable by O of n square, then for sure, O of n square, for sure, later in future it will give wrong answer or TLE. Maybe the Leetcode test cases are not that great for the last question, but for sure in future it will just go and say it's as a TLE. Quickly, let's jump on to the, but meanwhile the folks are joining in, can we please smash that like baby, and also can we just write down that how many questions you guys did? That would be super great. First one, pretty simple. Find the maximum achievable number. It just says that we are having two integers as num and t, and an integer x is called as achievable if it can become equal to nums after applying the following operations no more than t times. So basically I can apply this operation at max t times. Now what I can do is increase or decrease x by 1 and simultaneously increase or decrease nums by 1. Now what I want is to get the maximum possible achievable number, which means I want the maximum possible. So I will for sure try to have maximum possible number. It can proven that there exists at least one achievable number. Okay, I have one achievable number, but I want the maximum possible number. By the example itself, it's pretty obvious that, okay, let's say I choose a number. Here he chooses number 6, so he can reduce this number only once, and he need to bring this number equal to 4 anyhow by just reducing, by just modifying this number x. If he chooses number x, he can modify this number x and need to make it equal to my nums. So what he will do is 6 reduce by 1, it will get to 5, increase by 1, it will go to 4. So basically it is fixed. Oh sorry, yeah, why it is not being rubbed? Yep. Now number 4 is fixed. Number x I want to choose, and I want to maximize that number, so I will just put that number as maximum whatsoever it is. I know that both nums can increase, x can decrease. Now it can increase t times, it can increase t times, it can decrease t times. So for sure I will get my x by just saying nums plus 2 into t, and that will simply say me and give me my maximum x. So our result is nothing but nums plus 2 into t, and that is simply I can return my answer. So that was the first question itself. Let's quickly jump on to question number 2. Nums plus t, that is correct. So let's quickly jump to question number 2, but yeah, before that, can we smash that like maybe 20 likes, just 2 more likes? That would be super great. Question number 2, it's actually very standard DP question, very standard. When we say very standard, it's actually very standard, and we have seen this in our videos quite a lot, like this problem. Cool. If you have not watched, which means you have not subscribed, so smash that bell button so that at least you should solve daily questions and the questions which we do in the contest. Cool. Maximum number of jumps to reach the last index. Simply you are having a zero index integer array called as nums. of integer f of n integers and an integer called as a target. Now I have nums, and I have a target number. Now what I can do is I'm initially positions at the index 0. Okay, I'm at the index 0 initially. Now in one step I can jump to any index I, from any index I to any index j, which means I am starting at index I, so I can jump onto any index, let's say 1, 2, 3, any index which is for sure not equal to my I itself. So I can jump from I to j, that is j should be more than I. That is one condition. And also the absolute difference, it should be less than equal to my target. And when I say absolute, it will cover both. If it is minus, more than equal to minus target, and less than equal to target. So I will just say, okay, absolute difference of this, absolute difference of nums of j minus nums of I should be less than equal to target. Only then I can jump onto that jth index. Now what I want is to jump to get the maximum number of jumps, right? I just want to try the maximum number of jumps I can achieve to reach to the index, and for sure I should reach the index n minus 1. Now what is the standard stuff which we can do is, firstly, looking at the constraints itself, it will just easily say that, okay, I can try something of O of n square itself. I can simply try O of n square. What I will do is, let's say, and in this questions, simply, if you know that, okay, you have seen something like this, then simply jump on to any middle condition. Or even if you start from the one condition, you will just simply reach it. From one, I have how many ways to reach other places. I can maybe jump here, I can maybe jump here. Let me just decrease the size. From this one, I can jump here, I can jump here, I can jump here, I can jump here, I can jump here. Or if I think of vice versa, which means if I am any middle step, let's say I am at 4. So maybe I have reached 4 by jumping from 6, by jumping from 3, by jumping from 1. So I will just ask, hey bro, 4, what is the maximum number of jumps? Considering, okay bro, 4, let's say you jump from 6. One jump I will count. Okay, from 6, one jump is being counted. Then I will ask 6, hey bro, what is the maximum number of jumps you can give me? So I could easily see that at every index I, or let's say at every index j, I can have multiple such places where I can jump from. I can jump from 6, from 3, from 1. And please make sure that you can jump only when this nums of j minus nums of I absolute value should be less than equal to target. Considering it is happening, I can jump from these indexes, 1, 3, from these indexes, I can jump onto my 4 value. Simply, and what I'm concerned about is the maximum number of jumps I can produce. So I will just say, hey bro, I will just have any variable, usually it's a dp, so I can name this array as any variable, let's say dp. I will ask him, hey bro, if it is possible to jump at you from 6, when I say if it is possible, should be, okay, 6 minus 4 absolute value should be less than equal to 2, and that is happening. So I will just ask him, hey bro, if it is possible, and what I want is maximum number of jumps. So I will just ask him, whatsoever maximum number of jumps you have achieved so far. Or if you are jumping from 6, which means one jump you are having from 6, so you will ask, hey bro, what is the maximum number of jumps 6 you can give me? So it is for 6, it is for I. One jump from 6 to 4, one jump from 6 to 4, and also existing number of jumps which will be of dp of j. So by this I can simply go on, and it will just simply go on at every index and will ask for every of the previous indexes. So every index for j, I will ask for every of the previous indexes. And that's how I can simply go and find what is the maximum number of jumps, because ultimately I am doing a maximum out of it. And simply what will happen is, it will try to reach the end. It will just go and try to again ask for everyone, hey bro, can you please give me, hey bro, can you please give me, hey bro, can you please give me, and whosoever give him the maximum, it's good. I will just do a simply 1 plus a dp of I, and I are all the previous ones. It is, let's say j, it is all I variables. You can just take it by yourself, but it is j. It will just simply go and ask. If it is impossible, then for sure I need to have something. I will initialize my dp, let's say with -1, because ultimately you can easily see that if it is impossible, then you have to return a -1. So if it is impossible to jump at that location, I will just have it a default value, which is -1, which means my dp will never get updated, because it is simply getting updated by maximum value. So I need to have some minimum value, and for sure it just, okay, from one arrow I can have to targets. I just wanted a minimum value to be initialized for my DP, and I can initialize with -1 itself because I'm taking the maximum value. So with this simple steps, I can easily reach my actual final place. And that's how you can simply solve it. So simply, how you thought of, okay, firstly you thought, okay, n square stuff will work. You thought n square stuff will for sure work, which means at every index you can go and ask previous indexes, hey bro, what is the maximum value I can jump from you? Hey bro, just go and ask and say bro, else he will not listen. Ask, hey bro, can you please let me know, if I jump from 6, from 3, from 1, what is the maximum I can get? So one jump I will get from 6 to 4, one jump is already done. Then I will go and ask, hey bro, for 6, hey bro, please can you let me know what is the maximum number of jumps you can give me? That is, let's say I, index I. So he will just have, so that is how we are building up. And for sure, see, it's very easy to visualize 1D array. 1D DP, it's easy to visualize, and I will highly recommend that you should also make a habit of visualizing and solving 1D DP by simple, actually bottom-up approach and not recursive. It can easily be solved by recursive also, but 1D DP are always much easier to think and visualize in the iterative, which means bottom-up approach. Don't think of, you can also use a recursion and also then maybe memorize it. It's easy, but it actually stops you from thinking in 1D DP, because 1D DP, it can be in the array form also, which means if you start thinking 1D DPs in array, which means in bottom approaches, it will help you in arrays problem also a lot. So please start thinking of 1D. I'm not forcing you for 2D DP or more. I have shown you the recursion also, but please be familiar with 1D DP bottom approaches and get started with the bottom approaches of especially 1D DP, that you should be able to actually think, okay, I can use the previous state to bring the answer from my state, and previous is nothing but simply whatsoever previous indexes have occurred, and that's how you can simply solve it. And it's a very standard problem, very standard, and you can just think of it as any longest increasing subsequence. You could you just go and ask for previous indexes, hey bro, what is the longest increasing subsequence up till you? Then also the same logic and same stuff is applied. So if you had studied a longest increasing subsequence, then also you can simply solve it. It's that easy. Cool. Let's quickly see the code. It's pretty simple. Firstly, I initialize my DP with -1. But yeah, before that, if the folks are still watching, can we please smash that like video to 30 likes? 30 likes. Yeah, you guys are still watching and not liking that answer already. Okay, cool. 30 likes. Cool. 30 likes. So firstly, we initialize that DP, okay, with -1. Now at the index 0, I have just landed it. No jumps required. No jumps required, right? So a DP of 0, which means for index 0, number of jumps which I can do is simply a 0. Now I will just simply go and sorry, Amazon guy is here. No, don't know for what he's here, but yeah, I'll simply go and ask him, hey bro, can you please, I just simply go and iterate on all the i's. For all the i's, I go on for all the previous j's, right? So which means if I have this array right here, so if I am at the index I, I'll go and ask all the previous j's, hey bro, can I jump from you? Can I jump from you? So I will ask him, hey, abs of ai minus aj is less than equal to t. Abs of ai minus aj is less than equal to t. I will ask them if it is possible to jump, and also was it ever able to reach that jth also? So if that DP of j is not equal to -1, which means it was possible to reach j, and from j now I am moving to I. So firstly, making sure that, okay, it was possible to reach j itself. It was possible to reach j itself. And also from j I can move to I. From j I can move to I. So firstly asking, hey bro, it is possible to reach to j, and then from j I should be able to reach to I. Possible to reach to j, this step, which means a DP of j is not equal to -1, and from j I should be able to reach to I, which is simply saying that ABS value, that absolute value, should be less than equal to my target, which is this T target. And simply, if it is possible, then simply update my DP of I with maximum of existing value, because ultimately I am concerned about the maximum value. Okay, DP of I, one step, because you are jumping from J to I, and for J you will ask him, hey bro, what is the score for you? And this will score, and this will store, my DP of J will store the maximum number of jumps it is possible to reach to Jth index. I simply add a +1 because from J I am reaching to I, and update the DP of I itself, and simply ultimately I can return my DP of n-1, and that will be my answer, because ultimately I was concerned about reaching the n-1 step. Cool, that was for the question number 2. It's actually, see, if we had done longest increasing subsequence, longest non-decreasing subsequence, like this problems, then it is exactly same like that. It is a O of n square, same algorithm as that of longest increasing subsequence. Cool. For LIS, we have already studied two approaches, O of n log n and O of n square. So that is O of n square 1. Same, exactly same. It's just that it is just having different condition, that instead of being it should be more, it's just saying it should be absolute value should be less than equal to my target. That is how you can simply solve it. Cool. Let's quickly jump on to question number 3. Actually, like, now the interesting part will start. Now the interesting part will actually start. Question number 3. It's also like not that much hard, but yeah, it's actually a bit more tricky than the actual standard stuff, which means to actually think, okay, Aryan, what's going to be applied? I have seen something like this, but I cannot think of it. Now, we'll think of that, okay, how to actually think of these kind of problems. And the fourth one is legit. I have also provided the notes for it. It will be very, very, very awesome. It's actually a good question. Although it's like score as 5, but I'll keep this question as a score of 6 maybe, because it's actually a good one. If you have not solved it earlier, it's actually a good one. And please remember this one. This is okay for this also. Please remember this one. But yeah, for the fourth one also, please remember that you have solved something like this and add these in your notes if you have not yet added. And if you have not yet made your notes, then for sure you have not watched these 6 mistakes which I had done in my preparation. So please watch that so that you don't at least do it. At least learn from someone else's mistake, right? Cool. Let's quickly jump on to question number 3. Before that, can we smash that like maybe for likes 45? 45 likes. That was super great. Longest non-decreasing sub-array from 2 arrays. It seems like maybe we are going to apply something of longest increasing subsequence, but not. Let's see, because it is subsequence, not sub-array. Sub-array word, that is a very, very, very focused point to actually think that you should not go very deep into longest increasing subsequence wala thingy. Keep your stuff into sub-array, because it is one word which most of the people might have missed, and they would have started thinking of subsequences and not sub-arrays. So please make sure this word was very important for it. Let's see how. We are having a zero-index integer array called as nums1 and nums2 of length n. Now, I'm just saying that, okay, I can make my nums3 out of choosing for making nums3, I need to have value at every index, right? I0, I1, I2, I3, and so on. So for my, let's say I0, I can choose any value from maybe nums1 or maybe nums2. I can choose any value for that nums3. Now, for choosing that nums3, and if you guys don't know, my parcel is on the door, but still, I'll not go. I'll just wait. Maybe my flatmate will go up. He will take it, maybe. If he not, like I have to go, then yeah. Meanwhile, we will just simply go on. I'll just WhatsApp him maybe. Bro, can you take the parcel? मैं ले लूँ क्या? Can you take the parcel? Cool. Maybe like he is out of the door, so maybe he'll take it. But yeah, let's quickly jump on to question number 2. So nums1 or nums2. So we have this. We can make, for choosing this ith value of nums of 3 of I can either grab the value from nums1 of I, or I can grab the value from nums2 of I. Cool. Anyways, it can be done. Grabbing the value for nums3 of I, you can choose either nums1 of I or nums2 of I. Now, your task is to maximize the length of longest non-decreasing sub-array. Mark my words, it's a sub-array. It should be longest non-decreasing. And for me, it's just hard for me to visualize non-decreasing. So I think of as increasing with the same value also. It is how I study or I read these things. So I will just say longest increasing sub-array. When I say increasing, it means increasing with the same values. That like it doesn't make sense, but yeah, increasing with same values is not decreasing, right? Cool. So I have to make, my aim is to make a longest increasing sub-array. Now, basically num3, I have to make a longest increasing sub-array. Now, I have to return an integer representing the length of the longest increasing sub-array in nums3. And it just say, okay, what is a sub-array like? Now, for you will just simply say, okay, my one array is 2, 3, 1. My one array is 1, 2, 1. So what I can do is I can simply start from this one maybe, or maybe I can start from this 2. If I start from this 1, I can go to this 2 also. I can go to this 3 also. Simply, if I had, see, it is very important. You saw everything. It is very important. You saw everything, right? It is the reason I just showed you like this. Let's paste it right here. And then, because I want to show you every options, that how you have to actually start thinking of this, because it is actually not that easy. Okay, how you think of what's going to be applied. So think of, okay, you can start from 2, right? Which means because see, you can choose any element from here, any from here, any of here, from here. It's just that the condition is it should be increasing. So I can, if I choose a 2 from here, I can go and choose a 3 from nums1 itself. If I choose a 2 from here, I can go and maybe choose a 2 from nums2 itself. Maybe if I choose a 1, I can go and choose a 2 from the nums2 itself. If I choose a 1, I can go and choose a 3 from nums1 itself. Now you saw. Why, Aryan, why you just doing this? Because if you are choosing, let's say 1 would not have been there, but then 1 is not there. So maybe if you are starting from 2, then if you had gone to this 3, then let's say the next element is a 2 itself. Here, let's say it would have been a 2. So it would have been good that you just choose this 2, and then this 2. That is, or maybe this 2, or maybe this 2. So that is how it can actually increase. So basically, I'm just trying to focus that if I can choose any, this or this, but if I'm choosing, I have to go and ask for both of them, because ultimately I'm concerned about what is the next, and it should be more or equal to me. It is one such intuition which I can get, and for sure I can see that answer is 2 itself, because the maximum I can achieve is a 2. But Aryan, you just stopped and you just assumed that you will start from the starting itself. No, I did not assume. I'm saying, okay, it just started from the starting itself, and at max it can go to here. Now, as you can see that it cannot go forward. Okay, after 3 it's 1, 1. So no worries. Again, I can just start from this 1, and then again maybe if it is later, then I can go on, because it is sub-array. So if it is stopped here, it is stopped here. That's it. Then again it will start from here, if it is possible. And that is the interesting part, that you don't have to go and look for every possible ways. You just have to go and look for this, let's say for this, you just have to go and look for next number, or let's say you can just go vice versa. For this number, let's say name it as current. So for this current 1, I will go and look for this previous 1, or I can go and look for previous 2. For this particular current 2, I can go and look for previous 1 and previous 2. Now, it is easily visible that for this, let's say if both are not possible, so it will just break down here, which means it is done for sure. It is not linked with the further part. Now I will again start from here, because it is a sub-array. Sub-array done. Now again a new sub-array, because it's not possible to continue anyway. It is not possible to continue any further. So no worries, just stop it right here and simply start a new sub-array from this point. It is the intuition so far we have got from this question. Cool. Now with this we got, okay, its answer is 2. Let's look at the next example also for just a clear understanding. It's a 1, 3, 2, 1, a 2, 2, 3, 4. Simply I can go and start from anywhere. Let's say I started from this 1. I can also start from this 2. No worries at all. Let's say I start from 2, and then a 2, and then a 4. Or I can also do a 2, 2, 3, 4. Anyways, answer is 4. So easily I can see one thing, that something like this happening, that if I am at a particular place I can go, and for sure when I say I can go, it should be more or equal to me, right? And the folks watching in, can we please smash that like baby to 50 likes? 50, just 4 more, that would be super great. Now I can go to, from this nums1, I can simply go on to next nums1 itself. From this nums1, I can also go to my nums2, but at the bottom. From this nums2, I can go to nums2 also. From this nums2, I can go to nums1 also. So it is just showing that how my sub array can travel. And let's say if my sub array cannot travel, it will just simply break down, which means from this I cannot go forward. No worries, it will simply break here. Again, a new sub array can start from here itself. Right, and that is how we can simply see. And see, it's just a sub array, so I'm just concerned if it is, see, it's a sub array, so I'm only concerned about the previous value, because if the previous is for sure not available, which means when I am here, I will go and ask my nums of 1, and also I can go and ask my nums of 2 also, so as to continue, because it can also possible that it is continuing like this from nums2 to nums1. It can continue like this, right? So it is the same reason I just showed you all the possibilities. It can go from nums1, nums2, nums2, nums1, and the cycle can go on continue. So it is the reason. It is just 4 possibilities. One possibility nums1 to nums1, one possibility nums1 to nums2, one possibility is nums2 to nums1, sorry, nums2 to nums2, and then one possibility is nums2 to nums1. I can go on like this, and with this I can simply, and so for sure, if at any step it is not possible to go on further, and see, when I say I want to go on further, I'm only concerned about the previous value. And why only previous value? Because I need it to be continuous. If the previous it's itself not possible, then for sure nothing is possible, because I want sub array, and sub array is continuous. For that to be continuous, previous should for sure be there, and that will be having my values itself. So what I will do is I will have a variable for the current maximum length as, let's say, current1, which is saying if I have something for this at the top, it is current1. Current1 is saying, let me erase this, all the part. Current1 is saying for the nums1, okay, it is a current length, maximum length, if I end at nums1. Current2 will say it is a maximum length if I end at nums2. Previous of 1 will say, okay, it is a previous one of maximum length if I end at previous. Okay, if anything is ending at previous, it's a maximum length he can get. Now previous 2 will get, okay, it's a maximum length if he ended at this nums2 previous part. So if I want to get, if let's say if I'm saying I can reach to this current2, I can reach to this nums1 from this nums2, let's say 2 nums2 n2, I can reach to this nums1, which means for sure this value should be more than equal to my nums2 value. If it is possible, then I will just simply say what is the current1 maximum value. Now when I say current1 maximum value, it can be what? Either I can reach my current1 either from my previous 2, or I can reach my current1 from my previous 1. Anyways it is possible. So I will just say and ask him, hey bro, current1, firstly your existing value is 1, because for sure one number is itself one such a sub array. One number is itself one such a sub array. So for sure minimum value is 1 itself. I will go and ask him, hey bro, current1 is 1. Now you can come from previous 1, or you can come from previous 2. So if you can come from, when I say if you can come, it should be the value at current1 at nums1, it should be more than equal to the value at current1, sorry, it should be more than equal to nums1 previous 1 value, right? If it is, and see, when I say you can move, you should also always move on more than or equal to your value, right? So now if you can move, then I can simply update my current1 with the value as 1 plus, because for sure you are just going one step ahead, 1 plus previous 1 value, or which means when I say current1, so current1 will get, okay, current1 will be maximum of existing current1 value to 1 plus previous 1 value. If you can go from previous 1 to current1, or there's one chance you can go from previous 2 to current1, so it will be nothing but current1 max already value, which is maximum. Maybe it is maximum from here itself, or maybe it is 1 itself. So anyway, whatsoever, I'm just trying to maximize the value, because ultimately I just wanted the maximum longest sub array. So I'm just maximizing that simply. So I'll just ask him, hey bro, what is the current1 1 plus previous 2, because it can happen I can come from previous 2 itself. And the same goes for current 2. If I have a current 2 with me, let's say if I have a current 2 with me, let's say here it is current 2, so I can just simply say, hey bro, current 2, it is nothing but maximum of existing current 2. And when I say existing current 2, it is initialized with 1 itself. Existing current 2 is initialized with 1, because initially if I have only 1, so I can know for sure, okay, one sub array I can for sure get of size 1. So 1 is the minimum length I can get. Then it can be 1 plus, I can come from previous 2, 1 plus previous 2. And then I can also be say, okay, it is a maximum of current 2 comma 1 plus previous 1. I can come from previous 1 also. And for sure I'm only concerned about previous. Why previous? Because it's a sub array and it needs to be continuous. So it needs to be that way. Maybe it's not possible, okay, it's saying, okay, it is also not possible, then for sure it will never get updated. So just simply get it done. And see, when this is done and you saw, okay, you just have a previous 1, previous 2, current 1, current 2. When your current 1 and current 2 are updated correctly, now you need to update your previous 1 for the next current. So your previous will come here and your next current will come here. So next current will be here, right? So previous should update it. So I will just simply say my previous 1 is nothing but current 1. My previous 2 is nothing but current 2. And that's how my previous and current updated. And simply as my current is updated, it is saying current 1 is if I'm landing at nums of 1. What is the maximum length? Ultimately I'm concerned about the maximum length and I'm not concerned about landing at nums of 1 or nums of 2. So I'll just update my answer with existing answer whatsoever I have with the maximum of current 1 or current 2, because ultimately I'm concerned about the maximum length. And if anyways it is not possible, so for sure my previous will land back to a 1. And that's how I can simply start off again to have any new length, because it's a sub array. I hope that you guys got that. Just a quick smash, baby. I'll quickly show the code, then we will read the chats, or I'll read the chat first, and then we will quickly smash that. We can quickly go on to the code. But yeah, before that, can we please smash the like button to 6 likes? That would be super great. Aryan Mittal, can you memorize too? No, bro, you did not get it. Did recursion work in second? Anything which I tried second question by using binary search. Binary search won't work. It showed Emily when I approached this question by DP. Which question? Second. I think Leetcode is slowly becoming code forces. It's not the case. It was weird that they give DP in question 2 itself. That's a very standard DP. It's the question it was given for sure. It showed Emily when I approached this question by DP. It should not. You have not memorized it properly. I tried the question 2 by using binary search. Does recursion work in question number second? See, when I say DP, anyways, you can just go and ask the previous states. Previous state asking is nothing but recursion. Simply, you can go and ask. See, will binary search work for question number 2? Second questions, no, it won't, because see, let's quickly jump on to question number 2 itself. Firstly, we are just quickly switching question number 2. If you want to do a binary search, what will you search for? Like, what is the logic for binary search? It should be either increasing or decreasing. What we want is nothing close to that. We just want that difference to be less than equal to target. So for sure, I had to go and ask previous states, bro, what is happening for you? So it should happen something like this in binary search. There's no even intuition, like not even close to intuition of thinking of binary search for this. I didn't get your question. Saitharun, were you able to solve the question of binary search? Take or not take approach I was trying to, it was applicable. Yeah, the same thing goes on, take or not take, but simply you should go and ask everyone, hey bro, can I take you? And if I can, then please, can you just help me out if I can take you with the maximum value possible? But didn't get it. No bro, can you write the recursive to MS version? See, recursion is pretty simple. If you have any function, let's say this, right? and I am at the index I. Let's say one argument is integer I. Now, base condition, forget that. Whenever you have to write recursion, simply think of, if you have to find the answer, you will just go and find, okay, let's say it is the answer. Answer initialize with any value. Let's say I've initialized with the minimum value, which is -1. Cool. I will go and update my answer with what? I have to go and check for previous states. So I will just simply go and have a loop from int j is equals to 0 to int j is less than I and j plus plus. Just give me answer is equals to maximum of answer comma function of whatsoever you can give me. But please make sure that, okay, I am jumping one step, but it is jumping one step, which means function of j plus function of j. It will just simply go and ask me, hey bro, if I can jump from you, but I'm just considering I can jump from every j, but before that I cannot jump from every j. So add a if condition. If that absolute value of nums of j minus nums of I, it should be less than equal to my that value, which was t, target. So it should be less than equal to my target. If it is the case, I can simply go on and jump from my function of j. Now I can simply go and jump from this function of j if it is possible. Now it will just simply go and try, and for sure please modify the arguments by yourself, which means you have to pass nums, you have to pass k and all that stuff. But yeah, main argument is nothing but I. Now it will simply go on and try to check for that function of j. You just need to memorize that, simply just asking if dp of I is not equal to -1, return dp of I itself. Simple. Now simply saying, okay, it just keeps on going back. For this, it at any point of time, it will just simply return a -1. It will simply return a answer itself, because answer is nothing but -1. Now as it is returning an answer, so it will just simply go and check also that this function and this function of j, because this function of j, it can also return an answer. An answer can also be a -1. So it can also check, okay, that function of j, it should not be equal to -1. And this is being called again and here also again, but simply it is being memoized. So it will just call once. And that's how, see, recursion is always simple. So it is nothing but this particular recursion, which you can simply write down. This short recursion you can simply write down to actually solve your values. That's, see, anything, if in DP you can write by bottom up, for sure you can write it by recursion. Cool. I hope that you guys got it. Could you please explain the recursion also for question number 2? Recursion plus memoization से ही कर दिया था भैया. That is, yeah, see, for DP questions, whenever, see, I highly recommend, if it's a DP question, just simply do the recursion and then just simply memorize it. For 1D, I will highly recommend to think of the bottom approach for sure, because it will help you a lot. And for 2D and more, for sure, always go with recursion and memoization, because it's always very easy. If some optimization need, like, see, if you want to convert your code to bottom up, it's easy to convert from recursion plus memoization to bottom up also. It's actually easy, because there can be a chances in interview, because bottom up can be optimized more in space terms, but recursion cannot be optimized in space terms. So if the interviewer is asking you, hey bro, can you please optimize it? So you have to convert that to bottom up and then optimize it via space or maybe time also in few cases. So yeah, that is for question number 2. I hope that you guys got the recursion part, right? How to define question 2 is of 1D or 2D DP by simply the requirements of that argument. Key, if the question is having, see, in this case only index is sufficient for me to get every information. I don't require anything else. So the parameters, if it's a 1 parameter, it's a 1D DP. If it's a 2 parameters, are 2, which means it's dependent upon multiple parameters. It's a 2D DP or more DP. Cool. The best thing is solve in recursion, apply memoization, then apply bottom up approach. Then you will simply get better clarity. Yeah. Anyways, could you please explain recursion also for question number 2? Akhilesh, that is done. Third, TLE using sliding window. We'll go on to third again. एक मिनट, third तो यार किया था ना अभी हमने. That's firstly not a sliding window approach. It's just moving in the sub array part. Read the chat feed. That is done. MS Darshan. यार MS Darshan बहुत दिन से दिखाई नहीं दिया. Where have you been, MS Darshan? You didn't. like we couldn't see you for a meanwhile. ले आओ यार यहीं बैठे हैं हम. अच्छा ऐसा. By checking how many states variables are changing or affecting the answer. Correct. That is correct. Discuss daily LC also. Bro, I woke up pretty late and then everything was done. Aryan, you are Einstein. No, bro, I am not IT. Vamsi, hi, 5. Please do the gaming special live this Sunday. My laptop is about to die, right? I can't even do the editing and stuff. So gaming is like my video encoder, it won't support gaming streaming. Coders for which question? Vamsi, true. Tech up. Why are you not solving question 3 with DP? As every index we have 2 choices. See, you can name it as DP for, see, question 2, I guess everyone has got it. Right? Let's move on to question number 3. We had understood the concept of question number 3. It's actually DP anyways. You can say it as DP. You just memorize the previous state. That's it. You're only concerned about the previous state. So actually it is a question of DP also. Like you can name this as simple array problem also and a simple DP problem also. DP is nothing but you are thinking and you are thinking of the previous state of your X. Right? You're thinking of your X, which is the previous state. So simply getting the previous state itself, you can simply get an answer, or you can simply show that in the variable itself. Anyways, you can name that variable as DP also. But yeah, it's actually simply getting the previous state result. When I say previous, it is nums1 previous state and nums2 previous state, which is prev1 and prev2. Either it can be a variable prev1, prev2, or it can be a DP also. You can have entirely DP array also. But yeah, simply required variables are just 2 previous variables, which is prev1 and prev2. With this, you modify the current variable, which is current1 and current2. That's it. Bhaiya, that was very much similar to longest common subarray recursion problem. That is correct. That is actually correct. Last question. We will actually go on to last question 31. Jain, from which ID do you give the contest? I did not give the contest. Like I actually started because I was solving the Leetcode daily contest because Leetcode daily problem. I wanted the video to come to you guys soon, but then I solved it. I got an error. I was thinking that why my solution is not correct. Then I just went on to this. Around 15-30 minutes later, I started with the problem seeing that of this contest itself. It was not that hard. It was done, and then it was just completed. So then I have to actually make the the contest, the daily problem also after this stream. So that is one part which I have to do. Cool. From which we had intern in our college and was sick for a while. We had intern in our college and was sick for a while. Aryan Mittal. Okay, got it. How could you able to solve every problems, bro? What's the secret? It's not. See, it's just you have to relate it and think of, okay, I know this part. I know. See, I just specifically mentioned, right? It is just a sub array, right? Which means it needs to be continuous. If it is continuous, so thinking of a pattern out, okay, if it is continuous, which means I should be dependent upon the previous state for sure. Right? So if I'm dependent on the, and see, just simply go on at the middle part. Whenever to think of any problem, just simply go on the middle part and just start thinking from there. If you cannot, just go back in the starting itself and then think, and then again come back to the middle part and then think again. So simply making like this, okay, something like this is happening. I can simply go on to every of those because it's a sub array which is continuous. Continuous, which means I am dependent on the previous state. Previous state itself, or prev1, prev2, or DP itself. Anything you can take it. Cool. Please do it with DP memorization. Please, babe. That is done, Shivam Negi. DP plus memorization. I have found one pattern. If the constraints enable one maximum minimum count questions, then it is also of DP. If it provides greedy sliding window, that is not actually like. See, we cannot generalize a pattern with the constraints itself. It won't work. So yeah, let's quickly jump on to the explanation of question number 3. Sorry, the code of question number 3. It's pretty simple. It's just simply I have a prev1, I have a prev2, I have a current1, I have a current2. Simply I will just keep on updating my current1, current2 as I showed you here itself with the maximum value, and ultimately I will just update my answer with the maximum of answer, current1, current2. Cool. Let's simply take it. I have prev1, I have prev2, I have my answer also initialized. Now, if I have only one, so for sure only one sub array is possible. Just simply return a 1. Then I keep on going to from index 1 to index n. I'll just keep on going and I will ask, hey bro, I will just consider that current maximum length is current 1, current maximum length is current 2, and for sure I am landing at the ith index. So one sub array is for sure I have one such sub array, right? Because of length 1, I have one such sub array I have. Now I showed you that I have 4 options. One option is I'll go and compare my, let's quickly go back and make it like this back, right? I go and compare my nums1 of I with nums1 of I minus 1. If it is more, nums1 of I is more than nums1 of I minus 1, I'll say current 1 will maximum of current 1 comma previous 1, because previous 1 is the 1. When I say previous 1 is nothing but nums1, 2 is nothing but nums2. So previous 1 will be here, previous 1 plus 1, because I am landing onto the next element. So it will be nothing but maximum of current previous 1 plus 1. Else other option can be I am going from nums2 to nums2, which means I am going, okay, nums2 of I, if it is more than equal to nums2 of I minus 1. If it is the case, then simply update your current 2 with maximum of current 2 comma previous 2, because you are coming from nums2 itself, previous 2 plus 1. Or it can be a option that, okay, you are coming from nums2 to nums1, which means you are coming from nums2 to nums1, nums1 of I, nums1, let me change the color, nums1 of I, if it is more than equal to nums2 of I minus 1. If it is the case, nums1 of I, it is equal to nums2 of I minus 1, simply updating the current 1 because you are at nums1, current 1, or because you are coming from nums2, which is the previous 2 plus 1. And same goes for the last case, which means if you're coming to nums2 from nums1, which means if you're coming to nums2 of I from nums1 of I minus 1, see it is nums2 of I from nums1 of I minus 1. If you're coming from nums1 of I minus 1 to nums2 of I, simply updating your current 2 with maximum of current 2 comma previous 1 plus 1, and that's how you can simply get, okay, what is the maximum of current 2 comma current 1. Ultimately, if you have the current maximum so far, update your answer with the maximum of answer comma maximum of current 1 comma current 2, because it's a maximum sub array length I can have up till at that ith index, right? And then for sure update your previous with the existing current value, because for the next current, the previous will be this current, right? So update your previous with the existing current value, because ultimately as the loop goes on, your current 1 and current 2 will become new, and for them the previous will be previous wala current. So I just updated my previous current, and that's how ultimately you can simply get your maximum answer with this answer variable. Cool, I hope that you guys got it. If yes, can we please smash that like video to 65 likes? Just 2 more likes, 65 likes. That would be super great. We'll quickly jump on to question number 4, and for sure for question number 4 the the notes is down below in the description also, because it was actually hard to visualize why it is happening. It's the reason I made the notes prior to actually show you, because see, it is easy to tell, very easy, code is very short, everything is very short, very easy, but to actually show what's gonna happen and how is that you're gonna think, to visualize that, I just made this specifically, and you will love that. Cool. Kushagra understood. Third code is simpler kind of DFS. We cannot name it as DFS, but yeah, it is a simpler kind of a DPC. DFS is nothing but going on to a states, any way, any direction. You can think of a DFS from here and going on, but you cannot go down, right? From nums1 to nums2 at ith location you cannot go. So you can just say it as, okay, you can just go right, go diagonal, but you cannot go down. It is something you can think of, but I'll not suggest to think of DFS in this, because if you start for thinking of DFS, you will start think of graphs. Thinking of graph is way too extreme for this, so I'll not recommend it. But yeah, after understanding it, first thing, intuition will come up when you will start thinking in that pattern itself. Start thinking and how to think of that pattern. It's a sub array, which means it needs to be continuous. If it's continuous, it needs to be adjacent to each other. Adjacent, which means previous is for sure required. Previous required, which means I need to know the previous state. Previous state, which means maybe I can keep the states. States, which means DP. So it is how every word is linking to every other word and giving me some value I can add in my answer. Cool. Let's quickly smash that like video to 65 likes. Just one more like. That would be super, super, super great. Would we take nums 1 as minimum of nums 1 of I, comma nums 2 of I? Minimum of. It won't work. Just keep imagining any of such array. If you take nums 1 of I, why you are updating nums 1 of I? Is it saying that, okay, nums 2 of I, longest increasing subsequence? If you take minimum at every step, let's say if you take the minimum, then the example itself won't work, right? This example 1 3 2 1 1 3 2 2 3 4, you will take nums 1 as minimum, so it will take as minimum as 1. Last step minimum as 1, which means 4 will never come, so for sure your 4 is never there. Your answer will come as 3, but the answer is 4 itself. So the concept which we thought of, okay, taking the minimum and then making a longest increasing subsequence, that won't work, because firstly, that's the reason I specifically mentioned it's not a subsequence, it's a sub array. Both are different. So please don't think of a subsequence, think of it as a sub array. And for sure, taking minimum will just put you in a blunder, because in the example itself, you saw that taking minimum, 1 will remain and 4 will be gone. And for this case also, it is a 2 2 3. It will be how the minimum will look like. Longest increasing subsequence or sub array even is nothing but 3. That's the reason your minimum taking won't work. You have to take minimum, which you have to ask both of these stages, which means ask both num1 and num2, and that's how we can solve it. Cool. Third question is simply kind of deeper. That's good. Understood. Q4 much of a CP. That is actually true. Question 4 is much of a CP problem, but yeah, actually it's good because you should get exposure. And see, if you are in your college second year or third year, please keep doing CP. Especially in the first year, you should for sure do CP, for sure. When I see CP, it means code forces and code shift. For sure do it. Add coder, you can do it, you cannot, it's up to you. But yeah, for sure do code forces and code shift. It's actually very, very, very good for you. Aryan, please give your mind. I mean, can you exchange our brains, please, if you can? If it would have been, I would have exchanged. Thank you, Aryan. Understood. Thank you, MS Darshan. Thank you, Vamsi. Let's quickly jump on to question number 4. It's very interesting. Very, very, very interesting. And can we please smash that like by to 70 likes? 70 likes. 70. Apply operations to make all array elements equal to 0. Firstly, it's a very standard. As soon as you will look at the question itself, you will get to know, okay, one thing is going to be applied, that's for sure. But how to apply that, it's tricky. So if we are having a 0 index integer array nums and a positive integer k, cool. We can apply the following operations any number of times. Choose any subarray of size k. Mark my words. Choose any subarray of size k. Your subarray needs to be fixed of size k itself. From the array and decrease all the elements by 1. The only operation you can apply is decreasing all the elements by 1. Mark my words, it is only operation, which means choose a sub array of size k, that size is fixed, and also operation to apply is just decrease them and decrease all by 1. Ultimately your aim is to make everyone as equal to 0. Everyone should be equal to 0 itself, or return false if it is not possible. So, and I'm not concerned about the number of operations. Okay, how many operations I need to apply? Nah, I'm only concerned about if it is even possible to make all of them 0 or not. So with the first example, I have a 2 2 3 1 1 0. First thing which comes in my mind is I need to for sure make everyone as a 0. Right? Ultimately, my aim is like this. So for sure, this 2 also needs to be go to 0, which means from 2 it is a starting. So I need to take a sub array of length k and need to reduce everyone to 0. So I will just reduce everyone by 2 because for sure I need to reduce everyone by 2 itself. Remember this fact. It's the reason. it just specifically, as soon as we started with the problem itself, as soon as we started with the example itself, we just got to know, okay, we have to reduce every element to 0. Operations are not required. Operations are not concerned about. It's just if it's possible or not even. 2, I need to reduce it. Reduce 2. For sure, this 2 need to be reduced. So I will just try to reduce it to 0, which means I need to reduce all of these elements by 2. All of these by 2. Now here itself comes the interesting part. What if this element would have been a 1? If this element would have been a 1, I won't be able to reduce every of those by 2. For sure, to reduce this 2 to 0, I have to reduce entire sub-array by 2 for sure. I cannot reduce it by 2. If I reduce, it will become -1. Ultimately, the only operation I can do is decrease. So for sure, I can only decrease. I can never increase. If it is decreased, it can never increase, which means it can never reach back to a 0. So one thing, it is a parallel. See, right now I'm just going through the example itself. I'm not thinking the logic. I'm not thinking anything else. Just the example. While thinking the example itself, we got to know, okay, if by anyhow in my sub-array which I'm considering, any element is less or becomes less, for sure I'm screwed up. I cannot do it. So yeah, it is while thinking, okay, what might happen, ऐसा हो गया तो, होता है ना कि like we overthink, ऐसा हो गया तो, that is the same thing. I'm just overthinking, okay, what if it happens? Now it has become 0. It has become 0. Cool. Now let's go on forward. It is a 1. So for sure I will try to make, because see, it needs to reduce to 0. So for sure take a sub array and make it as a 0. So reduce 1, reduce 1, reduce 1. Simply getting a 0, 0, 0. And for sure it's a 0 itself. So simply a 0. It means I was able to get all the elements to 0. Now, what we saw initially, I just initially went on and thought greedily. For sure, no matter what, I know I have to reduce my starting to 0. For sure, I have to reduce every element to 0. I know I have to reduce my starting element to 0. If I have to reduce, simply drop it down to a 0. If I drop it down, so the entire sub-array of size k will also drop down, which means I, as an element I am impacting the next k minus 1 elements also. Which means I'm impacting the next k minus 1 elements to reduce it by my sum, which is a 2. Or my value, you can say right now. My value, I'm saying to reduce everyone next to me, which is everyone next to me, k minus 1, to reduce by me. Okay, reduce, and reduce. Now, thinking of it, Aryan, it seems very easy. I'll just simply think greedily and I will simply go and choose the sub-array of size k. I'll simply reduce all the values with the AI value, which means the next k minus 1 value, I'll simply reduce. I'll keep on doing the same stuff for every index. You cannot do it because the constraints are pretty big, which means for every index you are saying that you can go to next k minus 1 elements. For every index, next k minus 1 elements. Every index, which means n into k. Both n and k are 1e5. You thought of right, but constraints were stopping you from actually solving it. Now, I will use the same logic which we saw. Just see that how we can, because see, I know that I have to go at every index for sure, but modifying every value, maybe, because see, I was just modifying every value, then for this I'm modifying every value, maybe I can just take a sum or something like that. Okay, how much to reduce at every step? Because see, ultimately what's happening is I'm concerned about for this number, for this index, how much he has to reduce because of the impact of previous numbers, because the number I, it impacted the next k minus 1 elements, right? So it was impacted by the previous k minus 1 elements. Anyway, you can speak of anyways. If it is impacting the next k elements, which means, sorry, next k minus 1 elements, so it is being impacted by the previous k minus 1 elements. So I just need to know, okay, how much the impact is on this particular index so that I can reduce it by that value. That is ultimately how I'm trying to think of optimizing it, because I know I just need to get the impact itself. I'm not concerned about, okay, how much to reduce, how not to. I'm just, okay, what's the impact on this? So what we simply do is, we got to know one thing. If this is a sub-array of size k, this is impacting everyone, which is next k minus 1 elements. It's impacting the next k minus 1 elements. Or I can also say the same stuff that this see, whenever I'm saying, that's the reason, whenever I think, I just start to think from the starting itself, but then I jump on to the middle and start thinking from there itself. From a of I am saying it is being impacted by the previous k minus 1 values. When I say impact, it means, okay, let's reduce it. Yeah. When I say impact, what it means, it is having some impact. As you saw earlier, your 2 was having an impact on 3. Your this 2 was having no impact on 3. Why? Because of this impact of 2, its impact become a 0. Realize, see, these things will help you a lot. So please understand very carefully. This 2 had an impact on 3, but then this 2 had no impact on 3. Why? Because its impact, because as soon as this 2 had an impact on this 2, its impact became a 0. So its impact was actually a 0 and not a 2. So the 2 right here had an impact of 2, but the 2 right here had an impact of 0 on the 3. Why? Because the 2 previously had made the next 2 as a 0. So it has become a 0. So that its impact is actually providing it as a 0. So basically I'm just concerned about the impact, and that impact also from every element can change off. So I can just have the impact addition as the sum. So I will just say, okay, my impact on every element, I will keep track in the form of a variable called as sum. And also I know that my every element, it can change. It was a 2. Now it became a 0. So my a of I, let's say it is a of I. Let's say it is a of I. So a of I got changed to a 0 because of the impact. Let's say the impact was actually a 2. So because of this 2 impact, my a of I got changed. It became a of I equal to a of I minus my impact, which is the sum. I'm just naming my impact variable as a sum. So now it will become a simply 0. So now it will just simply say, okay, the impact is nothing but a 2. So I will just, impact is nothing but a 0. So it will just simply go and say, okay, in the sum add a 0, because for sure you are adding your impact values. Ultimately for 3 the impact is a 2. So simply reduce your 3 by the impact value. You reduce your 3 by the impact value. Simply you got a 1. It is the new a of I value. And then for sure you will simply go on moving forward. It is the intuition which we have got so far. Cool. Because I'm just concerned about the impact I will have for every element, and impact, as I showed you, I will keep track as a form of a sum. Now comes the actual visualization of this. To visualize that, I have showed you, although the maximum visualization has been done with this example itself, but it's a very rough part. Okay, something like this is happening. Actually, how it is happening, let's visualize it. Now when you say this, the height as I've shown here, it's actually representing a number. Let's say you can easily visualize it as, okay, when I say a, it is just saying I have represented the number value with the height of the number, right? If it is 5, now it should be entirely a, let's say 8. So the b will be actually a 3. It is just representing this form. Every number is representing by the height itself. Cool. Now please remember, it's the height, which means number is 5, number is 8. So if it is 8, so b will be nothing but a 3. Now the number is, let's say 11. So it was 5 plus 3, 8. So the number c will be nothing but a 3 itself. It is how I am representing my numbers in the form of a height itself, because height will help you visualize much better. Cool. Now what will happen is, I showed you that I will go at the middle part. Now as I go into the middle part, I need to know what is the impact, because I know my k is 4. So for sure this is index 0 to index 3, it's being impacted, which means this person will impact the other ones. I'm not sure until how far it will impact, but it will impact the other ones. Impact, it means sum. It will impact the other ones by what value? By a value. Everyone will get reduced by the a value for sure as we go on forward. So its impact is a. As I go on to my next, which is a of I, its actual value is a plus b. its actual numerical value is a plus b, because a is this height, right? Because of the previous sum, which is a, it will get impacted by what? It will get impacted by a itself, because when I say 2, I reduce every one by 2. So I will reduce every one by a itself. You will see, right? So I will impact every of those elements in this window of size k by my sum value itself. So I'm keeping track of that impact in the sum. And I know I need to reduce my next upcoming one, which means next a of I need to reduce it by my previous impacts which I have got so far. Previous, the number right here, current number is a plus b. A previous impact which I have got is nothing but a. So the remaining value is nothing but a of I remaining is nothing but b itself, right? A of I remaining is b, because the a part, which is at the bottom part, it is being removed because of the previous a itself, because previous a impacted my current a. As I know, I have to reduce my entire. So now you will see now your a of I is nothing but, your new a of I is nothing but b itself. But what is your new impact? What is your new impact? Which means you know that your index 2, it will get reduced by a because of this index 0. But your index 2 will also get reduced by index by value b because of the previous one, because the new length will be nothing but from 1 to 4. So your impact, earlier impact was nothing but a, but you saw your remaining a of I was actually b. So your new impact has become a plus b. Now your new impact has become a plus b. Cool. Now simply you will go on and ask your hey bro 2, you have been impacted by this value which is a plus b. So I just impact this value by a plus b. A plus b is gone. Remaining part is c. So here a of I, here a of I will remain as c after being impacted by this sum. Now if it is being impacted, still the remaining part is nothing but a c. So bro, the next impact you will provide to the next number is actually a plus b plus c. A plus b plus c, right? Because earlier the impact was a plus b. Remaining part, even after impacting you, the remaining part was actually a c. So you will impact the next person by a plus b plus c, and you will easily see the next person you will see in the list is impacted by a, is impacted by b, is impacted by c. A plus b plus c. So its remaining value will be nothing but a of I will be nothing but a d itself. So he will say, hey bro, I will impact the next number by a plus b plus c plus d. Which means from here to here, I will impact them by a plus b plus c plus d. But you will see he's saying I will impact the next number by this. But as soon as he's going to impact the next number, the length, which means the impact of this first number would have been gone, because the first number impact was up till this point only. So please bro, please reduce the impact as you are going to impact the next person. Before impacting the next person, as let me erase all these redundant things. Yep. So next number, as this bar is going to impact the next number by this impact called as sum. But you know the impact of this particular first element, first index, was only up till this range. Let me change the color. Was only up till this range. So for sure, as it's going to be impacting the next number, the impact of this would have been gone. So please reduce, as my window size is gone. Please reduce the impact, because I am not gonna impact him anymore. So I will just, before actually going on, I will just simply say sum is equals to sum, which is a plus b plus c plus d minus the actual impact, because he's actually gone from the picture. He's gone from the picture because the next is this. Next is this. He is gone. So reduce his value, which is a of I. A of I was actually a of I. A of I was actually a. So the new impact which he is gonna provide to him will be a plus b plus c. Sorry, it will be b plus c plus d, because a is actually gone. A is actually gone. Now the new impact, and for sure you can easily see that the new impact, I will just make it much bigger. Yeah, the new impact will be nothing but he will get impact as b plus c plus d. How? You know, b impact, it will give this b impact to him, because for sure, you know, remember ai is nothing but b. A of this a of I is nothing but C, a of I is nothing but D. All these are actually reduced to 0, which means it is reduced to B, it is reduced to C, it is reduced to D. Now it will say, hey bro, it is B. So it knows that it will impact him by B, it will impact him by C, it will impact him by D. By this I know that the impact is B plus C plus D, that I just reduced the previous gone impact. That's the reason. It's a greedy, we saw, okay, because we need to go greedy ways, and for sure we are removing the impact of whatsoever it's gone. So I had a window of size K, and the window of size K is having the impact as soon as the window moves forward, the impact of the previous K minus 1th element, I'm just removing that and just making that impact new. So now again, it's going to impact this by value of B plus C plus D, because we know the impact how we are keeping track of. For sure, its actual value was also B plus C plus D. So its new value will become a 0, right? Cool. And now as it goes forward, you will see that again, it will try to go on and move this impact, which is B plus C plus D to the next number. But before moving, please bro, remove the number which has gone. This impact B has gone. So reduce I impact B from here itself to actually impact the next number. So B is gone. So the new impact will be nothing but C plus D. And that's the reason. It's a sliding window. Impact is being gone to the next number. New impact, it will do a C plus D. Okay, its already value was a C plus D itself. So AI will itself become a 0. Cool. Now it will again go and try to impact the next person, but before impacting, our window is actually again going to change. So removing the C impact also. So it was earlier a C plus D, but before impacting, my C will also get reduced, the value which was actually this, right? And it will just simply become a D, and now it will impact me as a D value. Now simply if it is going to be impacting me as a D value, it will just simply say, okay, A of I was actually D itself, so it will become a of I equal to a D minus D, which is nothing but a 0. Now as it keep on going forward, it will try to impact the next number. When I say impact, it will just simply go and say, okay, the sum is nothing but a D minus this value, which is nothing but D, because the window size will again go, and this, although it's done, but yeah, simply at the last step, as the loop goes on, it just still goes to I plus 1, right? So that's the reason it will simply go and ask a D minus D, which is impact, and the remaining impact is done. So I don't have to impact any other number anymore. And that's how, as we reach the end, the impact should actually become a 0, because I should not be impacting any number anymore, which means all the impacts done should be completed as my array is ended. Else, if the impact is still there, which means I need to still impact someone, which means that someone still needs to be modified. If it is the case, even if after ending, if I still needs to impact someone, then for sure, even if after ending I still need to impact someone, then for sure his value needs to get changed, but array is still ended. So if the array is ended, the impact should become 0. If it is not 0, which means it's just saying I need to impact someone. If this sum is not becoming 0, it is saying I need to impact someone. And if I need to impact someone, which means someone's value should have got changed, but I have no one, for sure it is not possible. So if the sum at last is not a 0, then for sure I will return a false. Else, if the sum is 0, I can simply return a true. So with this, you can simply see that how we are simply solving it. And that same stuff which I have shown you above, I have a sum, I have a sum, I have a sum, I have a sum, and I'm simply getting the new sum by saying, okay, it is the window. As I'm going on to the next sum, I need to reduce the impact of this particular person. So I will simply reduce the sum by A, and I simply get the new sum as simply a new impact to the new person as B plus C plus D. And that's how. See, in the code itself, you will see that I am subtracting my A of I with the sum, which is the impact. And also, you will see if someone was remaining, if the A of I was remaining, you know, the sum was this A of I was still remaining after being impacted by A of I minus sum, it is still, my A of I is still remaining. So I will still add that existing, because I need to go and find my new impact. My new impact will be nothing but my sum, which is the actual sum A, and the new value which is remaining but A of I, which is B. So I'll just simply get the new impact. That's the reason I'll get the new sum by sum plus a of I. In the code itself, it's actually in these lines. So I'm just specifically showing you, okay, how this logic which we have seen is actually linked with the code itself. And for sure, as we saw, that as I'm going and my window size is actually moving beyond, because it's a window size of size k. So if it is done, which means my I is nothing but k minus 1. I is here k minus 1, right? So as my I can be more than equal to k minus 1 anyways, which means starting from 3, 4, 5, 6, which means starting from 3, I can keep on subtracting these values. I can keep on subtracting this. I can keep on subtracting this. I can keep on subtracting this. So starting from I is greater than equal to k minus 1, starting from this particular I, which means I can keep on subtracting my a of I minus k minus 1. So starting with this I is more than k minus 1, I can keep on subtracting my sum with the value of sum minus a of I minus k minus 1, which is my sum. You saw here, my sum was nothing but a plus b plus c plus d. I subtracted the value of a of I minus k minus 1, a of I minus k minus 1. So nothing but a of I minus k plus 1. I am subtracting the existing sum to get the new sum, which is a new impact on the next person, which is by subtracting this existing value, which is a of I minus k minus 1, right? It is, you will see at the code at line 13 and 14. And for sure, you saw everything here. Everything was perfect, like your relationship, right? But as we saw earlier, if I had a big value, let's say in the initial example, we were seeing like a 2 or 3. I asked you, what if a 1 is here? For sure, it won't work, right? So for sure, at any point, your impact was actually a. Your impact was a. So a should have been impacted, but impacting someone whose value is smaller, which means I'm impacting the next person by a, but his value is b, which is very small. You can see height difference also. So I'm impacting the next person by a, but his value is less than impact, which means his value is less than the sum which I'm impacting of him. So if at any step it is the case, then simply return a false. It is never possible to actually impact the next person. As in this case also, I was having the sum as 2. I was impacting the next person, which is 1. But the sum, by the impact of 2, he cannot bear this impact. He needs to be more. Actually, he needs to be 2 or more than 2 to actually bear this impact. So if it is a 1, he cannot bear the impact, and for sure he will be gone. So if your sum is more than your a of I at any step, simply return a false. You will see in the line at 6 to 7, if your sum is more than a of I, simply return a false. That's how it was. Just simple, this short code, simply going on to my every index by simply first saying if the impact is more than the existing value, simply return the false. Now simply update your new number with the after having its impact from the previous. So after having the previous impact, which is the sum, what is your new value like? Now if the still value is remaining, you can add this value in the impact itself. And for sure, if the window, you can actually move this window, which means if your I is more than k minus 1, so you have to remove the impact of the a of I minus k minus 1 by simply from this existing impact, which is a sum. So with this impact, you will simply be gone. Then ultimately, as this is entirely done, your ultimately last impact should be equal to a 0, because if this impact is not 0, which means your array is completely done, but still you have to impact someone, but no one is available for you to impact. Thus, it will simply just say as if it is a 0, answer is true. If it is not, answer is false, which means you should have impacted someone. So that's how you can simply solve it. That's the reason I just specifically mentioned. Thinking of it as greedily, it was very easy, but thinking how this impact thing is working, that's a specific reason I have to make this entire graph or entire this particular stuff, which means showing you in the height variation that how everything is impacting every other thing. I hope that you guys liked it. It took quite a lot of mehnat. So if we can smash that like maybe to 8 likes, that would be super helpful. Because after this video, I have to actually make today's Leetcode contest also. And if anyone else have any doubts, can you please smash that like maybe to 80 likes? Just 3 more likes. That would be super great. Thanks, understood. ये like ऊपर नीचे कौन कर रहा है? ये like I was maintaining 69. है या यहाँ लो 70 कर दिया मैंने भैया, स्ट्राम छोड़ दे रहा हूँ, फोर्थ ट्राई नहीं किया है अभी. Cool, no worries bro. Fourth is looking too tricky to understand. See, actually code is very easy, but thinking of why this is happening, how this is happening, how this variable sum is impacting my next number a of I, it's actually very tricky to understand. That's the reason I specifically made this entire stuff height wise to show you that okay, height is being removed because every number is being subtracted, which means I am reducing the height from every number. That's how. And maybe in future, how about you see a problem where actually you're reducing a height? It can happen. But yeah, that's how I specifically made something like this, because it's something actually tricky. Question 4 seems easy, but it is tricky. Yeah, it is actually. Bro, at last this question impacted my mind. Impact, pact, act. Please don't give this type of questions. It's not on me, it's on Leetcode. But yeah, Bhaiya, can you also solve today's questions of the day in the Leetcode live? We will get to know how you process information about the question and intuition. See, that's the reason I specifically keep the live contest and also the daily contest different. If you don't remember, there was one problem which occurred in the live contest, but still I solved it in actually daily videos also, because I need to give these specific notes, which means the proper notes for that problem, and also I need to make it short and concise, the video, because everyone can't watch the entire intuition and every stuff. So it's the reason I specifically, although I can just simply explain this here also, because the notes are kind of reddish and the code is also reddish, but still I am not thinking to do that in live, because for sure for that video it will be gone, which means everyone is concerned about that particular part and people are just concerned about, oh, it should be short, it should be this, that. But yeah, I'll have, that's the reason. Even if you study this problem in the live, let's say 1.5 months later, if we are still doing Leetcode daily, even if we have solved a problem in weekly contest, still I will make it's one video of live contest, because in that I will give you the proper notes of that. It's actually notes, it's good note, but it's not very proper. It was made in just half an hour, but actually to make the actual notes, it take around 1.5 hours to make for me, for that notes which you actually get in the videos of daily contest. So that is what actually it is having. You have not seen the LinkedIn post I have mentioned you. Tech up. Oh, like I saw maybe a message. I will see. There are actually thank you so much for actually firstly mentioning anyone who mentions. Firstly, very much thank you. For sure, I will, after making this video and after having my lunch, because I have not have breakfast or lunch or even anything. So after making the next video of today's contest, sorry, today's problem of daily, after having lunch, I will try to look at messages on LinkedIn and also on WhatsApp. So sorry for that, but yeah, bhai explanation काफी अच्छा था, but नहीं समझ आ रहा still. See, that will take time for you to actually see. That's the reason I'm specifically giving you notes. Open the notes parallelly, open the video parallelly. See, I'm saying I don't say for every question its score is 5, but still I assume its score as 6. It's actually a tricky question to understand. It's very easy to write down. It's very easy to actually say, okay, I will just have a sliding window and then I will reduce the number a of I. Writing code is very easy for this. Maybe even the thinking, okay, just get it done, it's easy. But to actually start thinking of the intuition, okay, how everything is being impacted by the previous I minus k minus 1 value, and then how I need to reduce a of I by every of the impact and all that stuff, it's actually hard. So please watch that part of last again, and it will very much help you. But please make sure to have the notes parallelly and also video parallelly, and then watch it, so that it will be very helpful for you guys. Questions to those daily problems. Yeah, usually I include it, but yeah, if you have any doubt, let's say if I mention sliding window, but if you think that you are not good at sliding window, simply go and watch our DSA 169 series. In that you will get the compiled list of amazing sliding window problems. Let's say if I just say you it's a problem of DP, or it's a problem of sliding window. So if you don't know, or if you have not much familiarity with the sliding window problems, then please go and watch the DSA 169 series sliding window questions. That's the reason I have compiled the proper questions in that DSA 169 series. And if anyhow you just want to practice any abrupt amazing questions, you can just go and look at the playlist of ours. I'll quickly show you guys. That's the reason I specifically mentioned that how to actually utilize the resources, right? Let me quickly
3 crore.
On
so 3 crore is a
that's the reason, like every time I just mentioned that how to actually utilize the resources. Whenever, see, I hope the screen is visible or not. Yeah, it is visible now. So that's the reason. Simply go and see whenever you have to do a DSA, whenever firstly at home, special video is here. See, whenever you just want to know any of these special videos, which means special content is being put. So if you just go on and come down, you will see live streams and special videos. So in this special videos, if you just hand onto it, you will just simply go. For the folks who are asking that how about the gold medals, like how you got and still you like did not studied, it was this video right here. And for the folks who are asking, okay, the DSA 169 series, it is this video. In this you have the entire sheet of DSA 169 series, which you can go and attempt it. So that is how you can simply go and solve it. And that has the amazing compilation of questions. That's a specific reason we have mentioned it right here, right? So utilize this special videos. It has the entire, see how to make the resume, what to never say in the interview, how to actually what mistakes to do. So everything of this sort is in this special videos itself. For the ones who are asking for projects, we also have a projects video for this. So that is how you can simply go and utilize this stuff right here. Cool. So please go and utilize that. And for sure, I always try to actually add any problems I see in this playlist. So if you just go and see, I have specifically mentioned another playlist I have made specifically for the problems which I see and I love the most. So if you just go on and see, there is a playlist by the name of top 50 150 interview questions. So it is the place which I keep on updating by any amazing questions I find in my entire journey, because it is, I can't increase that sheet. That sheet is the Bible. Cool. But to practice amazing questions intuition wise, it is the amazing playlist which you can go through. It has random problems. It can be of DP, it can be of array, it can be of graph, but it will be super interesting for sure, very different than the normal problems which you will encounter. It says, and I have specifically mentioned it, and still it is numbered 150, but still the videos are 52 because I will update it. And I will only update it when I want it. Although I have more than 500 videos, but I will not update it like without anything. It should be very special if I should update it, if I should add it in this particular playlist. So that is how you should use these resources. Cool. Can you solve the second question using recursion quickly? Bro, we solved it. Actually, it's very like we solved it. Actually, if you just go back in the videos, it actually was solved. Bro, please need too much interaction with you, not like problem solving stuff contest. We need some special live on every Sunday. See, special live won't help you guys, because for sure no one would come in. And see what people will ask, they can ask here itself. So I just think, okay, special life won't be required as such. But yeah, love of you guys, Vamsi and Rohan, Shivam, like it's just amazing. Samrat, where is the number playlist? Number theory playlist. It is actually in that itself. Mathematics and number theory. Is there any link for the resume review? It will be when we will reach 25k likes. For resume review video will be coming soon as we hit 25k likes. So that would be 25k special for you. हर contest में second question खराब कर देता है आज भी second question. See, it can be different. Second question, it can be sometimes easy, it can be sometimes hard. In this, if you had known this, it was actually easy. If not, then it can be a bit tricky, but But today, if you had learned second question, please remember it, how to solve it. Add in your notes, add in your DP thing, anything, but please remember it because it's a very standard one. So next time it should not happen that it should be missing. Cool. How you manage work, YouTube, relations together, create video on time management. To create video on time management, it needs time. I don't have time. Yeah, for sure we'll have it. But yeah, any other questions from any other of you guys? If not, then can you firstly please smash that like baby to 85 likes? That would be super lovely. But yeah, still not. Thank you so much for watching in. Thank you so much. Bye bye. See you guys. Goodbye. 85 likes possible if possible. Super great. Cool. Bye bye. Thank you so much. Goodbye. Bye bye. I have to make the video of Educator Contest, by the way. Cool. Bye bye. Today contest video coming around 1.5 hours or so. But yeah, that would be coming in to the next contest. Sorry, next problem.